Okay, so compounding interest. It occurs when interest is calculated on both the principal amount, so what you initially invest, and the accrued interest. So our formula is going to be A is equal to P times 1 plus R over N. Notice the N is only under the R, okay, to the N times T. So it's a little bit longer of a formula than just simple exponential growth and decay. P stands for the principal, which is the initial investment. Or initial amount, however you want to phrase that. But that's the principal. R is, of course, the rate as a decimal. That does not mean if it's already a decimal, just leave it. We've got to convert it to decimal form from percent form. N is the number of times per year the interest is compounded. I don't have time to write that the interest is compounded, but it's the number of times per year the interest is compounded. And then T is the number of years, or time in years. We'll write that, time in years. Okay, so we'll do what we did last time. As we're reading the equation, we'll try to identify with the numbers what variables those numbers correlate to. So then we can build our function and then we can evaluate it. So Laura deposited $12,000 into an account. She deposited, so that's her principal. So P equals 12,000. Some of you would rather just write it above the number, write the variable. You can go over to the side and list them all, however you want to do it. Into an account that earns 8% interest, so that's R, but R is not 8, it is 0.08. How much money will she have in 5 years? So that is T. T equals 5. If the interest is compounded quarterly, that is N, the number of times per year. Quarterly, how many times would that be per year? 4. Okay, 4 quarters in a year. So let's set up our equation here. A equals the principal, 12,000, times 1 plus the rate, 0.08, over 4 raised to the 4 times 5. Now, write that down, and then I want everybody to pick up their calculator. I'm going to do it too, but I want everybody to pick up their calculator because most people know how to set up the equation, but they don't get the right answer because they don't type it in correctly. Okay, so the 12,000 goes in. Since the only thing divided by 4 is the 0.08, you just type it straight across like that. 1 plus 0.08 divided by 4. It will divide it correctly. It will divide the 0.08 by 4 and then add it to the 1. We do not want to divide 1.08 by 4. Okay, and then raise to, here's where you have a choice. Either you go ahead and multiply the 4 times 5, or you must put it in parentheses. Okay, if you're going to multiply it out, go ahead and put 20. But if you don't multiply it out, let me show you what happens. If you don't put parentheses and you don't go ahead and just say 4 times 5 is 20, you're going to get something that is not the right answer at all. Okay, because your calculator follows order of operations, so it applies the 4 as an exponent, and then it multiplies the whole thing by 5. Okay, so the correct answer is approximately $17,831.37. Okay, the correct answer is not $64,945. Okay, that should seem way, way, way too big if we only started with 12,000. Okay, interest does not accrue that quickly. Okay, so let's look at number 6. Jack took out a 6-year loan for $25,000. So that is our principal. P is $25,000. To purchase a boat at 4.5% interest. So 0.045 is R. If the interest is compounded monthly, so how many months are in a year? 12. That is N. What will he have paid total over the course of the loan? So we've got PRN. We don't have T. What is T? 6. It's a 6-year loan. We want to know how much total he has paid out. So let's do that right here. 25,000. 1 plus the rate, 0.045, divided by 12, raised to the 12 times 6. Again, just type everything in straight across. Okay, and either go ahead and multiply 12 times 6 and get 72, or make sure you put that in parentheses. So over the course of the loan, he has paid out approximately $32,732.58. So that's a chunk of interest. $25,000, 4.5% interest for 6 years. You end up paying $32,000 total, almost $33,000. So almost $8,000 in interest. Just something to keep in the back of your mind, when you decide you want to buy a car and you're like, oh, I can get a loan. Just think about how much you're actually paying. Okay, let's do a couple more just to make sure we've got this down pat. Number 7, an investment account pays 3.9% interest, so R is 0.039, compounded semi-annually. So what does that tell us? N equals 2. It's twice a year. Semi-annually is twice a year. If $4,000, so that's P, is invested into this account, what will be the balance after 12 years? That's T. So let's set up the equation. A equals 4,000. 1 plus the rate, 0.039, divided by 2, raised to the 2 times 12. Okay, so it's pretty good. $6,358.48. Number 8, a savings account offers 8% interest compounded bi-monthly. Excuse me, did I say 8%? 0.8%. R equals 0.008. Compounded bi-monthly. I'm going to assume that means every other month. So N would be 6. I don't think it means twice a month. Bi-monthly. Yeah, every other month. 6. If Bob deposited $300 into this account, so P is 300, how much interest will he earn after 10 years? T is 10. So set it up. A equals 300 times 1 plus 0.008 over 6 to the 6 times 10. $324.97. Remember to include your units. Put your dollar sign on there. Right? It's a real world application. You always need units. Number 9. Yes, I'm sorry. Oh, good point. The question is how much interest will he earn? So that's how much money he has. So we need to take away the original amount. So thank you, Marvin. You are absolutely correct. That is not the actual answer to the problem. This is the answer to the problem. $24.97. Gotta pay attention to those details. Number 9, suppose you invest $750, so P is 750, into an account that pays 3% interest. R equals 0.03, compounded weekly. How many weeks in a year? 52, very good. How much interest, here's another one, it's not asking for the balance, it's asking for how much interest will you have earned after 20 years. So 750, I'm just not going to write this one down. 1 plus 0.03 divided by 52, raised to the parentheses, 52 times 20. Okay, that's how much the balance is. We've got to go back and subtract the principal to get the amount of interest. $616.35 is the amount of interest. So for 20 years, that doesn't seem like a lot of interest, but there are a lot of factors to consider when you're investing money. Okay, the more you invest, obviously, the more you're going to make. The longer you invest, typically the longer you make, or the more you make, because a lot of times the longer you're willing to invest something, they'll a lot of times give you a better interest rate. If you're just going to invest it for a short term, they're not going to give you as much interest because they don't get to hold on to your money as long. So just some things to consider.